Hi, welcome back to Internet Client Engineering. In this video, we're going to have a look at the World Wide Web system architecture. I'm sure many of you have used the web, and what we're going to do here is look under the hood to find out what the web system architecture looks like. The web is also governed by a range of protocols, and we're going to look at some of these protocols. These protocols are standardized protocols, standardized by the World Wide Web Consortium, or W3C. And if different systems want to be part of the web, if they want to interoperate, then they're going to have to make use of these standard protocols. So if you want to build a web browser or web server that participates in the web, the way to do this is to build it in such a way that they implement the web standards. Okay, let's have a look. So the web is a client-server architecture. There's a web client, which is your web browser, and it connects through the internet to a web server. So you can think of the web server as a software program that's running on some machine sitting in the internet, and that program, the web server, might do more than just serving web pages. It might do some business logic or some computations, in which case it's called an application server. And sometimes data might be stored in the database. Some processing is done in a web server in order to retrieve information from the database to serve it back to the web client. When the web server gets a request from the web client, so the web client, for instance, is a web browser, when it gets that request, so someone types in a URL on the web browser, the web server receives that request and then gets information from the database, constructs a web page, which is then sent back to the client or to the browser. So here are the components of that software architecture, which is basically a client-server architecture. And the protocol by which the web client talks to the web server is called the Hypertext Transfer Protocol, or HTTP. The word hypertext actually means a web link. A piece of text, when you click on it, jumps somewhere else. For historical reasons, it has been called the Hypertext Transfer Protocol, or HTTP. Now, we have typed in URLs or web addresses in the web browser when we use the web. And every resource on the web is identified in a standard way using what is called a uniform resource locator. And the uniform resource locator has a standardized format. So it starts with a protocol and then colon dash dash and then domain name colon and then the port number, and then this is followed by the directory and then the resource, for example, the name of the file. The protocol can be HTTP, HTTPS. HTTPS is a secure version of HTTP, and we're going to come back to that later. Or you can use the older internet protocols. These protocols are still sometimes used, such as Telnet or FTP. Domain name is the name of a domain like www.latrobe.edu.au. And port number by default is 80. So you can specify a port number colon 8080, for instance, if you're using the port 8080. But if not, the default is port 80. If you don't specify any port number, it defaults to 80. And what's the use of the port number? Well, the port number is used in the HTTP connection, because the HTTP connection is built on top of a socket connection, and to do a socket connection, you need the port number. The resource is the corresponding directory of the resource. So here's an example of a URL where index.html is the name of the file that is the home page of the La Trobe University website. Now, because 80 is default and the home page has a default file name, so it could be index.html or welcome.html, so we can leave that out. And what we might get is something like this. And if you type that into the browser, it actually uses port 80 and it retrieves the page called index.html. So the HTTP protocol is built on top of the TCP connection. So when you type a URL into the web browser and you want to send that request for the web page to the web server, first of all, a TCP connection is made between the web client and the web server using port 80, right? Suppose no other port number specified, so 80 is then used. And once the TCP IP connection is established, then HTTP requests are sent. And there are various types of HTTP requests. There's the HTTP GET request, and then there's the HTTP POST request. So, for example, you want to access that particular web page. So you type that URL http://www.latrobe.edu.au/students/timetables.html into the browser. So the first thing that happens is a TCP connection is then formed between the web browser and the web server using port 80. And then the second thing that happens is that a HTTP request, and that request is called GET, capital GET, followed by students/timetables.html. That is the HTTP request that is sent. The GET command is shown here. So this GET command is sent after a TCP connection has been established between the client and the server. When the server sees a GET command, it then knows what to do. This GET command is part of the standard HTTP protocol. Standard way to handle a GET command is to then look for the directory students in this example and look for the file called timetables.html. And once the server finds that, it then sends this HTML document all the way back to the client. If the web page has images, then you can grab the images as well. Right? So let me give you an example of the retrieval that happens. If you go to View, Developer, Developer Tools, notice it then shows you the URL of this web page and some other information. It also tells you something about the network, tells you something about the timelines. Okay, so let's try and retrieve a particular web page. latrobe.edu.au. You can see on the right hand side now, the whole series of GET requests are issued in order to retrieve the different parts or different components of the Latrobe University web page. And you can see on the right here the timelines, the how many milliseconds to retrieve different components of the web page. So you notice here that the first request is a GET request. So this GET request is sent to retrieve the HTML page. It's actually index.html that sits in a default directory somewhere on the web server. And once index.html is sent back, so it's very that's the first page that being retrieved here. Then retrieve the different components of the web page. So you notice that a web page is not just constituted by one page. It is formed by a number of different resources. Right? So for example, in the web page, there's index.html, which is the main file corresponding to the home page. But you notice that there are a number of different images. And then there's a CSS, which are style sheet files. There are images like JPEG files and so on that are present. And then there's some JavaScript code that's also embedded within the web page. Therefore, the home page is just not one file. It is a set of files. So there's index.html, and then there's core.css, there's styles.css, there's preview.jpg, logo.png, and so on. So there's a whole collection of files that goes to make up the home page that you see right here. And you notice that to get each of the component you issue a GET request, right? And so there's a whole range of GET requests here. So 178 GET requests, you notice, just to retrieve the different files that go to make up the home page. And there's the time to retrieve each of the different components in milliseconds. And you notice that you need to get the index.html first, and then our index.html has links to all the other components. So you notice that there are some parallel requests here. So a number of different images, right? So there may be 10 different images on this page. This would be retrieved using 10 concurrent GET requests for each one request for each image. And so hence you can see these parallel lines here because certain files for the web page are being retrieved concurrently. Okay. So instead of just getting a static web page as we saw previously, static web page means the URL or the file name is fixed. We can also get a dynamic web page. Right? Dynamic in the sense that we specify a set of parameters in the URL. So it's not just a fixed URL, but there are name and value parameters associated with the URL. Yeah, you can think of this like almost like a method call, right? Because you have a set of arguments or set of parameters, name equals value pairs. So one example of this would be Google, right? So if you click on Google, you notice that this URL is actually a parameterized URL. So here's an example here. You're doing a book search. You type in two attributes and two values, title equals e-commerce, year equals 2000. And that is then sent using a GET request to the server side. And the server, when it receives the two attributes, title equals e-commerce and year equals 2000. An example of that is Google. So let me just show you an example. Okay, so let's look at an example in Google. And this is a good example of a GET request with parameters. And say if we type in a particular query, Yosemite Park, you notice at the top here, this is an attribute called Q equals, and the value of the attribute is Yosemite plus park. Right? So here is the value, and here's the name. So there's only one name value pair that is shown there. So I could change this, and that corresponds to typing the information into a web form. Right? So Yosemite National Park, for instance. So you notice that this is now updated from Yosemite Park. Now it's Yosemite National Park. Right? So whatever you type in here is basically added to the URL, and a GET request is sent. So the GET request will be get space and then Q equals to Yosemite plus National plus Park. The information that's entered by the user in the form will be sent over to the server using this type of GET request. Instead of a GET request where the names and values are all part of the URL, we might make use of what is called a POST request. The POST request is different from the GET request in that it sends the name equals to value pairs separately instead of being part of the URL. So for instance, in the example that we saw previously, in the GET command, there's just one message, which is GET, and then followed by everything, including the name equals value pairs. But in a POST request, there are multiple messages. So the first message is post /servlet /book search. That's the first message. And then subsequent messages then contains the name value pairs, like title equals e-commerce and year equals 2000. So the difference is that in the GET command is just one message, which has everything. In the POST command, you have firstly the POST command specifying the book search, which is the program that's going to receive the name value pairs. and then the name equals value pairs are sent separately. What I've just shown you is a simplification. In fact, there's a whole heap of header information, what's often called header information, being sent. So instead of just post servlet slash book search, it might have other attributes like from, user agent, content type, content length, and then followed by the name equals value pairs. So in the previous example, we are sending all the name equals value pairs to a program called book search in the web server side. And you notice that some special characters have been used, right? So it's because plus and percentage and even the tilde sign in tilde ICC have a special meaning, right? So if you wanted to specify that in the content of it, they need to be written differently, right? So instead of typing slash, because slash can be interpreted as part of the command, instead of typing slash, we type percentage 2f. Instead of dash, we might have percentage 2d and so on. So the idea here is that if you use the code for the characters instead of the character themselves, it is then considered as data rather than used as a command. Okay, so there's a lot more information on the HTTP protocol. In fact, it is a web standard, and many of the internet protocols or web protocols are specified using this RFC convention. So if you look at RFC 2616, so here we are. This is RFC 2616, and from 2014 onwards, it was replaced by a set of RFCs instead of one RFCs. Right. So you can see these were the people, the first designers of the HTTP protocol, including the inventor of the web itself, which is Tim Berners-Lee. Right. So all those details about the different requests are specified here, the GET request, the POST request, and so on. And there are details of it here. But we'll come back to some examples of this later on in the subject. So if the server is okay with the request, it will then send a reply back to the client. So the server will send a message 200 OK, for instance, back to the client. And 200 OK is then followed by the requested page, all the requested data. In this video, we have looked briefly at the client-server architecture of the web. We have looked at the HTTP protocol, which is the standard protocol used in the web for communication between the client and the server.